Okay, so for this episode of How Do We Wire It, what we have here on our screen is an example of a spark ignition system with a vent blower, or better known as an inducer motor. Now, with this type of furnace, we need to understand that we have a vent motor, okay, or an inducer motor as it's normally called. That motor is used to remove any sort of leftover combustible gases that may be still stuck inside the heat exchanger, so that we don't have a reaction or a bad light off. It's also there to help push your flue gases through the heat exchanger as the furnace is actually lighting off. But it also, almost in some ways, it can act like a safety. Okay, on a lot of your high efficiency furnaces, the inducer motor is going to be there, but with that inducer motor, you're going to have a pressure switch. That pressure switch is located right here. That's the symbol for it. Okay, and really what that pressure switch is doing, it's a proving switch. It's proving that the inducer motor is actually spinning and working, but it's also proving that there is a pressure difference inside the heat exchanger. Now, if that pressure switch does not close, that tells us that there is a problem. That problem could be a couple of different things. Okay, that problem could be that, well, obviously the inducer motor maybe didn't start like it's supposed to. Maybe the inducer blower wheel itself could be dirty. It could be a clogged flue pipe. It could be a cracked heat exchanger, just to name a few, that would cause that pressure switch to not close. It's a proving switch. It's a safety. Okay, because now we have to think about it. We are in gas. It's a gas furnace. Gas is a combustible material. If it's not properly set up or not working properly, I can create an explosion. I can damage the furnace. I can even level a house if it's not working right. So the safeties on a lot of our furnaces are vitally important to make sure that they are wired correctly, the way they're supposed to be in the system, and we have to make sure that they are working correctly when we are working and maintaining and doing work on any sort of gas-fired equipment, whether that's natural gas or propane. Okay, so with that being said, let's talk about how this actually gets wired. So we have a door switch. Okay, the door switch, as I always like to call it, that's the dummy switch. Okay, that's really another safety in a gas furnace. The door switch has to be closed in order for electricity to now flow through the rest of the circuit. Okay, because we don't want Johnny Homeowner there to start working on his furnace and then put his hands inside a blower wheel that's actually spinning at full RPMs. Okay, that's going to be a little bit dangerous. Okay, so the door switch is our very first line of defense when it comes to any sort of wiring on a furnace. In order for that furnace to work, the panels for the door or for the blower section of that furnace needs to be in place. Okay. Now, when servicing a furnace like this, you can bypass the door switch, maybe simply jump it out or put a magnet on the switch itself just to keep it closed while you're doing your troubleshooting and what have you. But that is the very first part of the operation. Now we have a transformer, which we all know how that works. We have a primary and secondary side. And the primary side is obviously going to be supplied with 120 volts. Secondary is going to be 24 volts in most cases. We have a rollout switch. We have a high limit switch. We have a fan switch, pressure switch. Okay. So again, there we are. We have our control devices, rollout switches, high limit switches, and pressure switches are all safeties in a gas furnace. We have our simplified thermostat here, R and W. Okay, vent motor, again, that's our inducer motor, our blower motor, ignition module, and gas valve. So how do we wire that? Well, here we go. We got L1 and neutral, or L1, L2. So when we are wiring this, obviously we have to start off with L1, because L1 is what's bringing power into our furnace. Out of L1, I want to bring that power down into my door switch. Okay? Out of that door switch, usually when you're looking at a furnace like this, it's probably going to go right into a transformer. Okay? That transformer could be mounted right on a circuit board. If it's a newer model, maybe, type of furnace, then you might necessarily maybe just have a transformer mounted inside the furnace itself. Okay? So that door switch right there is our control device for our transformer. If that door switch is open, I kill my power to my transformer. So that's where I say it's a safety. Okay? We don't want anything bad to happen when somebody is working on it that maybe not be qualified for it. Okay, so I'm going to complete that circuit. I'm going to go and I'm going to use a nice color blue here. Okay? That blue out of my transformer, I'm just going to come straight back out. Okay? And I'm going to go right back to my L2. I'm just going to complete it right there. Okay? So, that's our very first, if you think about it, our very first circuit in the operation of this type of furnace. So now what do I do? Well, it kind of gets a little crazy here. I have a couple of loads that I got to power up here. You know, I got a vent motor that's going to be operating off of 120 volts. I got a blower that's operating off of 120 volts. So how am I supposed to wire this? Well, we know that in the basics of all electricity, you got to have a source, path, switch, and a load in order for us to have a complete circuit. So I'm going to take my two loads in this circuit, and I'm just going to separate them. My vent motor is a load. That's a motor. My blower motor is a load as well. So they're going to be wired in parallel. All right, so let's take our blower motor first. Okay, we know that we got to have a blower fan that's going to move air across our heat exchanger when our furnace actually heats up, right? So I'm going to come out of my door switch. I'm going to say right here. Okay, I'm going to go right here. I'm going to come down, and I'm going to go into my fan switch first. Because, right, that's a temperature switch, right? That's a symbol of a thermostat, right? So probably about 140, maybe 150 degrees. That thermostat's going to close, right? Once that closes, I'm now going to be able to turn on my blower. Okay, and now I'm going to send that one back to my neutral, right? Or my L2. All right, I'm just going to go this way. Now, when we're looking at diagrams like this, okay, this is sort of like a pictorial diagram. It's not necessarily a ladder diagram. It's a pictorial. Because when we look at any piece of equipment, nothing in wiring is going to be all nice and neat, and you're going to be able to easily identify where things go. You're going to have to look at any wiring diagram, whether it's a pictorial or a ladder, and you're going to have to, unfortunately, get down on your knees, sit on your service bucket, whatever it is, sit on your butt, and physically pull the wires and look at the wiring diagram that goes with that furnace to see where these things are, to see if it is wired correctly. Now, over time, with more experience and more training that you get, obviously it becomes a lot easier to know how things are wired and where things are supposed to be and where they're located inside a furnace. The only way you're ever going to get that experience is by physically doing it and getting in front of that unit and looking at the wiring, comparing your apples to your oranges. What do I have? Here's my wiring diagram. Okay, here's my wire. Here's my power coming in. Where does that wire go? Sit there and physically pull the wire. Does it go where the wire says it's supposed to go on the ladder diagram? Okay? So, that's what we just did here. Remember, source, path, switch, load. All right? For our transformer, we have our power source. Here's our source, our path, our switch, and the primary side of the transformer is our load, right? So for our blower, we actually have two switches in series with each other, if you kind of think about that. Here's our source, our path, our switch, right? Here's one switch. Here's our path again, right, which goes down to another switch, path, load, and then right back. So troubleshooting your equipment, you break it down just like I am explaining here how to wire it. You break it down into smaller groups. Once you're able to do that, your troubleshooting is going to be a lot easier to understand and make sense of what is actually going on. Okay? So, we completed those two circuits right there. But I still got one more to do. I got my vent motor. That's a load. But I have to have something there that's going to control it, right? Source, path, switch, load. Okay, so where's my switch that's going to control my vent motor? Looking at the diagram. If you said the combustion air blower relay, you're correct. That is your control device that's going to start and stop that motor. So how do I wire that? Well, here we go. We have on our diagram here, I might just come simply right out of my door switch here. Okay? If you look at your door switches, you may or may not, again, depending on the furnace itself, the manufacturer, what have you, it may just come straight out of a door switch. But those junction points are going to be somewhere in that circuit. You have to physically look and compare your apples to oranges to see where these things are. So for the sake of this, I'm just going to come right out of my door switch like this. Okay? So technically I have 3 wires that are going to come out of this. Okay? And I'm going to come in to one side of my relay, my normally open contacts. Just like that. Out of that normally open contact, I'm now going to power up my vent motor, just like that. Okay? I'm going to come back out. Here's my L2. And I'm just going to send it right back to my L2, just like that. Okay? So, you may ask yourself, wait a minute, how is this going to work? I don't understand this. Wait a minute. Well, we're going to get there. I want you to just take a moment to just comprehend what we just did. I just wired 3 loads in parallel with each other. The line voltage side of this furnace. Now we're going to get into our 24 volt side, the control side of it. 24 volts, that controls everything. It's known as the control voltage. Okay? So, I got to power up, in order for me to even get 24 volts, I got to power up my transformer on my 24 volt side, right? So here, we got red. Red is going to come out of my transformer, and I'm going to come right into my thermostat, right? R. Red. Okay, red wire on a thermostat is my 24 volt power. Out of my thermostat, my W, I'm going to go in 2 separate directions. They're going to actually be in parallel. Okay? I need to send power to my 24 volt coil so that when my thermostat closes and actually calls for heat, I am now going to energize the relay coil on here, which will then close these contacts to turn on my vent motor. But I also need to be wiring my safeties, 1, 2, 3, in series with each other, so that I have some sort of safety device that's going to open and take my circuit out in the event of some sort of unsafe situation, whether that's a rollout, whether that's a high limit, temperature gets too high, or my pressure switch, the pressure difference inside my heat exchanger is not achieved. Okay, so to do that, I'm just going to use a different color, red. Okay, so I'm going to come out, and I am going to wire in my 24 volt coil. Out of my 24 volt coil, I'm going to go right back up to my transformer, my common on my transformer. Okay, now when dealing with commons off of your transformer, they could be different colors. Okay, sometimes they're blue, sometimes it's black, sometimes it's some color. Okay, so what you have to physically do is you're going to have to look at that circuit to see where your common actually is. Usually, 95% of the time, the red wire that's coming off of your transformer, that's your 24 volt power, and that's usually going straight up to the thermostat upstairs in the home. Okay, so that's one circuit there. Again, source, path, switch, load, right? The 24 volt side, my secondary, that's my source. Here's my path. The thermostat is my switch. The coil is my load. And I am coming right back up to my secondary side of my transformer. So now, like I said, I got to go in 2 separate directions here, right? They're going to be wired in parallel. I still have to do my safeties, 1, 2, 3. So out of my W, and again, you may not necessarily have 2 wires coming right out of the thermostat. That junction point could be anywhere in that furnace. It could be at a circuit board, it could be at a terminal strip, it could be wherever this person wired this furnace. So you're going to have to look and find that wire. So out of my W, and I'm just going to come right here, just to kind of safe, make it a little neat for everybody. I'm going to come out. I'm going to come right into each one of these switches in series with each other, one right after another. My rollout switch, I'm going to come out. All right, going to come down. And out. So, I'm at my pressure switch. Where do you think my connection should be in this diagram? If you said the ignition module, the Honeywell ignition module on the 24-volt connections there, you're absolutely correct. Because now I am using my 24 volts. Again, remember, these are safeties. Okay, we need to make sure that this thing's going to operate safely. So in order to do that, my safety controls, my high limit switch, my rollout switch, and my pressure switch all need to be closed in order for my ignition module down here to receive 24 volts. In order for it to even receive the call for heat. Okay? Because where does that call for heat come from? That call for heat comes from the thermostat. My thermostat is right here. So once that switch closes between R and W, I'm going to send my 24-volt signal out to my relay coil, which is going to turn on my vent motor, so that I can now start purging the furnace of any sort of combustible gases that are inside the heat exchanger, if there are any. But I'm also going to be sending a 24-volt signal out to my safeties. My safeties all have to close. The only way my pressure switch is going to close is if that vent motor is spinning and I have a clear path, and my heat exchanger is in good condition and it's not cracked. Remember, the pressure switch is sensing that pressure difference being created from that vent motor, inducer motor. That guy right there, that's very, very important. Okay, to understand what that pressure switch is doing. Okay, so once that pressure switch closes and it proves that there is a draft and that there is a pressure difference inside my heat exchanger, it's going to close. Once it closes, I am now going to send my signal to my ignition module, and now I can begin to make my furnace operate and actually light off. So to complete that circuit, all we're going to do is we're going to come back out of my 24 volts here. Okay, this is my common. Come out. And I'm just going to connect my common. Boom. Just like that. And to wire the rest of this, it is honestly very, very simple. I mean, when you're looking at any ignition module, usually they are pretty self-explanatory. Everything is pretty much labeled for you. It tells you where your gas valve wires are supposed to be wired, where your ignition wires, your sensors, all that stuff are all going to be wired. So for this, I'm just going to use green. I'm just simply going to come out of my valves and just go in one side, come back out the other. And I'm just going to wire in my gas valve, my 24 volts. So really the sequence of operation of this type of furnace is once my thermostat calls for heat, my inducer motor is going to start to spin. Once my inducer motor spins, my pressure switch is going to close. And as long as my other safeties that are in my furnace are closed, because your high pressure switch, your high limit switch, your rollout switches are all normally closed switches. The only way that they're ever going to open is in the event of either a high limit problem or a rollout problem. Now, a rollout is when the flame rolls back out at you. Instead of going into the furnace like it's supposed to, it rolls at you. That's a rollout. Okay? That, again, that could be a couple of problems that is caused by that. Okay? But anyway, if it happens, it's an unsafe condition. That safety switch is going to open. Again, notice it's a temperature. It's a thermostat. It's going to open on the event of a sense of flame. It's going to pop. When it does, it's going to kill my ignition module. And when my ignition module can't receive a call, I'm not going to ignite my gas. I'm not going to energize the gas valve. Therefore, I'm not going to have any heat. The furnace is going to go into a lockout. Okay? So once my safeties are all have proven that everything is all good to go, my ignition module will now send the signal to my gas valve to open, which will now ignite my burners. And once my burners ignite, my little flame rod or my flame sensor is going to pick up a microamp signal, and that microamp signal will be sent back to the module, telling the module that you had a successful light off of the gas. The furnace will continue to run until it reaches about 140, maybe 150 degrees, depending on the manufacturer. And once that happens, my fan switch is going to close, bringing on my blower motor, which will now deliver that warm air into the space so that I can now deliver the heat. Once that thermostat satisfies and the room reaches its temperature, the thermostat opens, and when it opens, it de-energizes the coil on for my vent motor. That de-energizes, so that guy's going to open, shutting off the vent motor. And when that vent motor stops spinning, that pressure switch is no longer going to sense that pressure difference, and it's going to open. And when it does, my 24-volt signal to my ignition module is now gone. My gas valve is going to close. The burner is going to shut off. Once the furnace cools off enough, my fan switch is going to open, usually probably about 100 degrees or so, maybe 120, depending on where it's set. Once that opens, my blower fan is going to shut off, and the furnace is now at rest, waiting for the next call for heat to occur. And once that happens, the entire sequence of operation starts all over again, and the furnace will light off. And that's how you wire a spark ignition system with a inducer motor.